Good evening, everyone. I am Manju, the Academic Coordinator at I2 Global Virtual Learning. So I am excited to welcome you to today's demo class for 12th CBSE Chemistry. First, let me introduce our esteemed tutor, Mrs. Sumbul. So she has over 10 years of experience in teaching chemistry and is renowned for her interactive and student-friendly teaching style. Now I would like to introduce our student for today, Jiteshwan. So Jiteshwan is a dedicated student. He got to deepen his understanding for chemistry for grade 12. So Mrs. Sumbal, the class is ready for you. And Jiteshwan, feel free to ask questions and engage with the material as much as possible. So she has included so many images like for you to understand. Some simulations have been included and you will be also try it for live. So let's make this session for more engaged and more informative. So Mrs. Sumbal, ma'am, over to you.
Okay. Thank you, ma'am. Hello,
Yes, ma'am.
Jitesh.
Hi, ma'am. Good
How are
evening,
you,
ma'am.
beta?
Fine, ma'am. How about you, ma'am?
Yeah, I'm also good. Can I call you Jitesh? Is
Yes,
that
ma'am.
okay?
It's fine, ma'am.
Okay. So tell me something about yourself.
Ma'am, I'm Jitesh, ma'am. I'm studying in Sri Chaitanya Techno School
Okay.
in 12th standard, ma'am.
Mm-hmm.
So it's a kind of an integrated school, and I'm also preparing for NEET.
Okay, very good. So, do you like chemistry?
Yes, ma'am.
Okay.
I like 10th chemistry, but once I started to enter 11th and 12th, the chemistry started to become tough.
Okay, let's change your thoughts about chemistry. So, like since you are in 12th standard, have you started with some of the topics?
Yes, ma'am. I have started, ma'am.
Mm-hmm. Have you understood those or any problem did you face there?
No, ma'am. I understood, ma'am.
Okay, very good. Okay, so myself, Sumbul Fatima, I'll be taking your chemistry here. I'm the chemistry mentor at I2 Global. And let's start with electrochemistry. Is that
Yes,
okay?
ma'am. It's fine with that, ma'am.
Okay, very good. Do you know anything about electrochemistry?
Like how to say, electrochemistry means using like batteries and stuff. We have to change chemical energy to electrical energy.
Okay, very good. Okay, the word electrochemistry, anything that you know about that word?
Um,
Okay, it's okay. I
not
respect.
sure about that, ma'am.
Okay. Let's start. I'll present the screen. Just let me know once it is clear. Is it okay, beta? Screen.
Yeah, ma'am.
Okay. Okay, so we are starting with electrochemistry. See, the word electro, it tells us about the meaning. Electro means anything which is related to electricity. Okay. And the word chemistry means anything that is related to chemical reactions. So when you see that your electricity is converted into chemical reactions, or sometimes many reactions might be there where chemical reactions are converted into electricity, we call it as electrochemistry.
Yes,
Okay.
ma'am.
Have you seen a torch working?
Yeah, ma'am. I have seen it, ma'am.
So what do we do in that torch, beta? We just put a small cell into it, and because of that, it gives us light. Okay.
Yes, ma'am.
So cell is having some chemicals present inside them. Some chemicals are present inside the cell. So what happens? We convert this cell, this chemical energy into light energy.
Yes, ma'am.
Okay. If suppose we are using this cell in any kind of electrical appliance, so we will say that the chemical energy is converted into electrical energy.
Yes, ma'am.
Okay. So electrochemistry is the interconversion of the two forms of energy. It is the interconversion. Sometimes electricity converting to chemical reactions, sometimes chemical reactions converting to electricity. Okay. This chapter, beta, we will study the two parts of this chapter. Number one is the electrochemical cell and number two is the electrolytic cell. These are the two parts of the chapter.
Okay, ma'am.
Electrochemical cell and electrolytic cell. Okay. Electrochemical cell is very new for us. We haven't gone through it ever. Electrolytic cell you have studied earlier when you were small. You used to study about a topic known as electrolysis.
Yes, ma'am.
Anything that you remember from electrolysis?
Electrolysis means like chemical energy to electrical energy.
Okay, chemical energy to electrical energy. Any
Or
other thing that you know?
breaking down of water molecule.
breaking down of water molecule. Very good. See what happens here, beta. Electro again. Electricity. Lysis is a word that gives you the meaning breakdown. Okay. So electrolysis means breaking down of a component into its ions is known as electrolysis. Okay. We have studied water number of times: tap water, salty water, sea water, ocean water, but you cannot divide this water into its ions in hydrogen and oxygen. Okay, we cannot convert it. But what happens, beta, if you want to convert it into its ions, if you want to divide it into hydrogen and oxygen, you can use the process of electrolysis there. Okay.
Okay, ma'am.
See, what will happen in the process of electrolysis? We will have a tank. We will have an electrolytic tank. This is known as electrolytic tank. Or you can call it as electrolytic container. Okay. In this electrolytic tank, we have the two rods made up of metals, made up of graphite, made up of platinum, or any other material that is able to conduct electricity. Okay. These two rods are connected to a battery, positive terminal and the negative terminal. The positive terminal of the battery is connected to the rod, which is known as anode, positive anode, and the negative is known as cathode. Okay, we have the ions present here in the solution. When you pass on the current from the battery, what happens? Suppose you have taken NaCl here, salt. You have taken a spoon of salt, dissolved it in a little amount of water, make it a dense liquid and pour it here. It will conduct electricity. What happens when it conducts electricity? It will be converted to Na plus and Cl minus. Okay,
Yes, ma'am.
the positive will go towards the cathode, means the negatively charged cathode, and the negative will move towards the positively charged anode. This is the process known as electrolysis. Clear? Anything you want to ask from here, beta?
No, ma'am. I'm okay with it, ma'am.
Okay. Electrolysis, where the electricity is converted into chemical reaction. Okay. By using the current, we have made NaCl into Na and Cl. See, sodium is solid, beta. It will be deposited here. Sodium will be deposited here on the, sodium will go here on the cathode. Okay, you remove the cathode from the solution, take out sodium, scratch sodium from the cathode, and you can separate it out. Chlorine is a gas that will be liberated here at the anode. Again, you take out, you take out anode and collect the chlorine gas. Chlorine is yellowish green in color. Okay, this is the process how you get the different type of ions from the solution.
Okay, ma'am.
Okay, electrolytic cell is very new for us. We haven't gone through it ever. It consists of two different type of cells. Okay, one is one half cell, other one is another half cell. Okay, means we are going to have one anode in the one and another cathode in the another half cell. That is why it is known as half, because it consists of only one electrode, either anode or cathode. That is why we are calling it as half cell. Okay,
Yes.
both the half cells are connected to an ammeter or a battery. You know, an ammeter is used for reading the current.
Reading the current, ma'am.
Okay, so we have taken, let us suppose, zinc rod. Okay, and this is our anode. To the other side we have cathode, and here we have taken copper rod. The rod is made up of copper. Okay, now what will happen, beta? You will have some ions here in the solution. Which ions? Ions should also be of the zinc, because we are taking a zinc rod, so the ions should also be of zinc. Let us take zinc sulfate. You can take any salt of zinc. You can take zinc chloride also. You can take zinc nitrate also, any salt. Okay, we have taken zinc sulfate. Another is your copper rod. Here we are taking copper sulfate solution. CuSO4. Okay. Now, when you will pass on the current here in the solution, the Zn from the rod will jump into the solution in the form of Zn2+. Okay. And it will leave behind its 2 electrons. Another zinc will also jump into the solution in the form of Zn2 plus. It will also leave behind 2 electrons. Okay.
Yes,
Other side, your copper 2 plus will go towards the cathode. Another copper 2 plus from the solution will move towards the cathode. Who is remaining in the solution, beta? Sulfate. SO4 2 minus, SO4 2 minus, they are present still in the solution.
okay, ma'am.
Okay, this is how the reaction takes place. And they are connected with the help of a bridge, which contains a salt inside it, and therefore we call it as a salt bridge.
Okay, ma'am.
Okay, we call it as a salt bridge. Salt bridge because it is a bridge which is carrying some salt inside. That salt can be your KCl, that salt can be your NH4Cl. What is the function? It is connecting your two half cells. Okay, like you have two different cups, you are having two different glasses, you want to hold them with one hand. So you can pour the fingers inside and you can hold them together. The same thing is the function of the salt bridge. It will bring the two cells together by holding them together in this manner.
Yes, ma'am.
Okay, this is salt bridge. Understood? Any problem in this, beta?
No, ma'am. I understood, ma'am.
Okay, electrochemical cell, it will convert chemical energy into electrical energy.
Okay, ma'am.
Okay, electrolysis, electricity into chemical reaction. So we have seen interconversion. Sometimes chemical is converted into electrical, sometimes electrical is converted into chemical.
Yes, ma'am.
Okay, I will show you some images related to this topic. Can you see here?
Yes, ma'am.
Okay, this is electrolytic cell, beta. Is it clearly visible?
No, ma'am. It's only half visible, ma'am. I guess.
Now is it okay?
Yeah, ma'am. Now it's okay.
Okay, so this is electrolytic cell. Okay,
Okay, ma'am.
you are having the electrolyte, anode and cathode is there. When you will pass on the current from this battery, beta, what will happen? The positive, you can see they are attracted towards the negative, and the negative are attracted towards the positive.
Okay, ma'am.
This is the process, electrolysis.
Okay, ma'am.
Okay. Okay, see, one more I will show you. See this one. Is it visible?
Yes, ma'am. It's visible, ma'am.
Still?
No, ma'am. Now it got stuck.
Okay. Now see, you can see here that your zinc is jumping into the solution, beta. See, zinc is going into the solution in the form of Zn2 plus.
Yes, ma'am.
And the electrons, they are going towards the another electrode. And the copper is reacting with those two electrons to convert itself into copper.
Yes, ma'am.
Okay. This is how the process of electrochemical cell takes place. Okay. I will show you one more. See this one. This is visible.
Yes, ma'am. It's visible, ma'am.
You can see, beta, that your zinc ions are going into the solution in the form of Zn2 plus.
Okay, ma'am.
And your negative charge, this blue is the negative charge which is moving towards the cathode.
Okay, ma'am.
That is moving towards the cathode, and your copper 2 plus from the solution reacts with it to convert into copper.
Okay, ma'am.
And we also have a salt bridge in the center that will pass on the electrolytes, ions into the electrolytes. Okay,
Okay, ma'am.
see one more. See here. Let us start. This is the galvanic or the voltaic cell, also known as electrochemical cell. Okay, so here if I select, beta, the left beaker with zinc nitrate solution.
Okay, ma'am.
And the right beaker, if I select it with copper nitrate solution and I turn it on, so that will always give you the value as minus 1.1 volts, minus 1.10 volt. Okay, now see how the reaction takes place. See the molecular scale. Your Zn2 plus will move into the solution. See, 2 plus ions are coming in the solution. Slowly,
Yes.
slowly, all the ions at the size of the zinc rod will be reduced. Okay, now see the other. The two electrons, this black color is the two electrons coming from zinc. They are reacting with the copper from the solution.
Okay, ma'am.
Again, Okay.
Yes, ma'am.
You know, this is how the reaction takes place, and for every process, for every type of salts, the value is different. Okay, like here in the case of zinc copper cell, it is showing you minus 1.10 volt. But for different type of cells, beta, the values will always be different, and that will be a constant value. Okay, whatever the amount of zinc and copper you will take, it will always be 1.1 volt. Is this okay?
Yes, ma'am. Ma'am, but so in this process, the ions from zinc go to the copper side and get deposited there.
Yes. And the copper from the solution goes towards the electrode, react with those two electrons.
Okay, ma'am.
Okay. Okay. I'll give you the same link. You also try it yourself.
Okay, ma'am.
I'm sharing the link with you. Okay. Just go through your chat box, beta.
Yes, ma'am.
Just click on the link and present the screen. Let me also see it. Okay.
Okay, ma'am.
Do it.
Ma'am, is my screen presenting you?
Yeah, I can see it.
Yes.
Start the process. Okay, you can set any left beaker.
I'll go with zinc itself, ma'am.
Okay, okay.
Zinc and
Copper.
copper.
Anything you can take.
Okay,
Okay,
ma'am.
and you turn it on, you will have 1.10 volt negative. Okay,
Yes.
now just try to change it. In spite of copper, take something else. For silver, the value is minus 1.56. If you change zinc, just change zinc. Minus 0.80. Okay, now see their molecular scales also. Okay, here the electrons are adding into it. Means your hydrogen electrode behaves as anode here, behaves as cathode here.
Yes, ma'am.
Okay, see the next one. Here they are joining together. It means they are behaving as anode.
Okay, ma'am.
Understood?
Yes,
And it
ma'am.
will have a fixed value minus 0.80 whenever you are taking hydrogen silver type of electrode.
Okay, ma'am.
Okay? Understood?
Yes, ma'am, I understood.
Okay, stop presenting your screen. I will give you some questions. Let's just have those also.
In the chat itself, ma'am.
No, 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 not in the chat. I have presented my screen. Can you see?
Yes, ma'am.
Okay. Okay, so the question number 1 is the type of cell in which electrical energy is converted to chemical.
Electrolytic cell, ma'am.
Very good. Inert electrolytes are?
All of these.
Oh, very good. Perfect. Next one, in an electrochemical cell?
In an electrochemical cell, anode is positive, anode is negative. Anode is positive, negative. Anode is positive, ma'am.
Anode is negative.
Oh, cathode is positive, yes.
Okay, see, for all the cells, beta, anodes are always positive. But in the case of electrochemical cell, an anode is negative.
Okay, ma'am.
Okay, next one.
In galvanic cell, cathode is always made. Galvanic means it's an electrolytic cell,
Yes,
no?
correct. No, 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 electrochemical.
Electrochemical.
Mm-hmm.
So cathode is always made. Cathode means in electrochemical, cathode will be positive.
Mm-hmm.
So
Good.
it will be on the left, ma'am.
Right. Left side is always anode, beta. This is anode.
Okay, ma'am.
And the right side is always your cathode.
Okay, ma'am.
Cathode is always right hand side and is positive.
Okay, ma'am.
Okay. Salt bridge is used.
A combined two cells responsible for not glowing bulb maintain electrical neutrality, does not pass ions. Ma'am, 1 and 2. Option A.
Option A, 1 and 2. Acha, it combines two cells. Good. It is not responsible for
1
glowing bulb.
and 3. 1 and 3.
1
I
and
got
3.
I got mixed up
Electrical
with the
negativity.
points.
Correct.
Yes,
Okay,
ma'am.
it is responsible for glowing bulb because the electrons are going towards the another side.
Yes, ma'am.
They are moving towards another side. Okay. Okay then. Any problem, Jiteshwan? Anything you want to ask?
No, ma'am. I'm thorough with the chapter.
Okay, you are thorough with it. Okay, so let's just stop here.
Okay, ma'am.
Okay. Okay then. Yes.
Yeah, Sumal ma'am. Yes,
Yes.
ma'am. Thank you so much for this wonderful session.
Thank you.
So, Jiteshwan, how is the class?
Yeah, ma'am. It was very good, ma'am. I was
You
able to
enjoy?
understand all the concepts and the things.
Fine, everything. Do you have any doubts anymore?
No, ma'am.
No, everything is clear.
Yes, ma'am.
So, you're happy with these sessions, right?
Yes, ma'am.
Yeah, fine. Okay. Then, okay, ma'am. Thank you so much
Okay.
for this
Thank
class.
you
And
so
we'll
much.
be contact you, Jiteshwan.
Okay.
Thank you,
Okay.
Jitesh.
Thank you.
Okay. Bye bye. Bye, Jitesh.
Bye,
Bye.
ma'am. Thank you, ma'am.
Bye, ma'am.